Imagine this. Two subatomic particles, once linked, can remain connected even when separated by the vastness of space. Measure a property of one, and the other instantly mirrors that change, no matter the distance. It's a connection that seems to defy the laws of physics as we know them. This is quantum entanglement, and it sounds like something straight out of science fiction. So, the big question we're tackling today: is quantum entanglement a real phenomenon, or just a spooky fantasy cooked up by physicists? Let's dive in. Quantum entanglement sits at the heart of quantum physics, the branch of science that explores the bizarre rules governing the microscopic world. When particles, like electrons or photons, interact in certain ways, they can become entangled. This means their fates become intertwined, their properties correlated in a way that classical physics simply cannot explain. It's a fundamental concept, but its implications are so strange that it's natural to wonder if it's truly a part of reality or just a mathematical curiosity. The idea of particles being linked across vast distances with such instantaneous correlation has understandably led to skepticism. Even Albert Einstein, despite being one of the fathers of quantum mechanics, famously dubbed entanglement spooky action at a distance. Common misconceptions often portray it as a way to send information faster than light, which would violate the very foundations of relativity. So, is this just a theoretical oddity, a mathematical trick that doesn't actually reflect the real world? To understand why entanglement is considered real, we need to delve into the core principles of quantum mechanics. Before measurement, quantum particles exist in a state of superposition, meaning they possess multiple potential properties simultaneously. It's only when we measure a particle that it chooses a definite state. What's remarkable about entangled particles is that this choice seems to be linked. When one entangled particle is measured and its superposition collapses into a definite state, its partner's superposition collapses instantaneously into the corresponding state, no matter how far apart they are. Crucially, this isn't about sending a signal. It's a fundamental correlation woven into the fabric of quantum reality. Landmark experiments based on Bell's theorem have provided strong evidence against the idea of hidden variables that would predetermine the particle's states. These experiments consistently show correlations that are stronger than can be explained by classical physics, firmly pointing towards the reality of entanglement. The sheer weight of experimental evidence is the most compelling argument for the reality of quantum entanglement. Numerous rigorous experiments performed by independent research groups around the world have consistently demonstrated this spooky action. The violation of Bell's inequality, repeatedly observed, leaves little room for doubt that these non-local correlations are a fundamental feature of our quantum universe. The Nobel Prize in Physics 2022 was even awarded for groundbreaking experiments with entangled photons, further solidifying its place in scientific understanding. So, is quantum entanglement real or just spooky fantasy? The scientific evidence overwhelmingly points to the former. While it remains deeply counterintuitive and challenges our classical understanding of the universe, quantum entanglement is a genuine, experimentally verified phenomenon. It's not about magic or faster-than-light communication, but rather a fundamental interconnectedness at the quantum level, with profound implications for fields like quantum computing and quantum communication. Now, what do you make of this mind-bending reality? Do you find quantum entanglement spooky or fascinating? Share your thoughts and questions in the comments below. And if you're eager to explore more of the strange and wonderful world of quantum physics, be sure to check out our other video on Suggest a Related Topic, e.g., the basics of quantum mechanics. The link is on your screen. Thanks for joining us on the Cosmic Cipher.